Hello, welcome to the podcast. It's October the 4th, and I'm Les Pounder. With me tonight is Ash Hill and our special guest, Chris Bensen. Hi, Chris, how's it going?
Oh, thanks for having me. Going good.
We have to say, Ash has alluded to this already before, but that impressive machinery behind you, sir, that is fantastic. Come on, tell us all about that rack behind you.
Chris, can you hear us?
Chris?
I can hear you. Yeah, something happened with the audio.
Okay. Well, we wanted our guests to know, what is this amazing background that you have behind you? What is this? What are we looking at?
This is the world's largest Raspberry Pi cluster that we know of. So it has 1,050 Raspberry Pis in a 4 foot by 4 foot by 6.5 foot, 4 server racks basically in a blue box. It was originally intended to look like a blue British telephone booth from a certain television show that I'm legally not obligated to not say, but I think you can gather the name. It turns out that's copyrighted. I had no idea.
Is it? Wow.
Yeah, and not by the British police. They built it 100 plus years ago, and the BBC copyrighted it.
That's awesome. So what you built there, this entire rack, this wonderful piece of machinery, what's your background? Is this your day job? Is it just something you do for a hobby?
Sure. My job, I work in developer relations or developer marketing. It depends on the time of the year when they change names and stuff. But I work at Oracle. I've been an engineer for, gosh, I started as an intern if anyone, I'm going to date myself here, at Borland Software back in the mid 90s, just out of high school. So I learned from some of the greats. My background is compiler theory. I did distributed databases as my thesis. So pretty low level, kind of stuff. I worked on, I came over to Oracle in the early 2010s, 2011, something like that. And I worked on Java for a number of years. And then in 2018, found myself kind of recruited over to the marketing team because they were working on some cool projects, and I had toyed with working on a few of those with them, and they just wanted someone to do more full-time sort of stuff. So I know, engineering side of things because I'm an engineer. I don't consider myself marketing, but here I am in a marketing role at Oracle doing developer relations. So I try to inspire developers. That's the goal here, and from kids to adults. Hopefully it's, try to get a parent with their kid to build one of the creations that I make. I mean, if you want, I can start picking up. I have various different things in the garage, from a Lego car, which is what made the Oracle Red Bull thing happen. Yeah. So we sponsored Oracle Red Bull because of an idea that I had with a Lego car. Here, I'll just show you.
Yeah, grab it.
Please.
We love Lego, so no brainer. Oh, hello.
Ooh, it looks cool.
That is very cool. Is that a Pico on there?
Yeah, so there's a Arduino Nano.
Oh, sorry,
because you need to control the motors. There's a brushless DC motor and a RC servo motor. That just works better to control that from a microcontroller.
Yeah.
And then there's a Raspberry Pi. This is a 4 8 gig. And then we've got a camera. There's some custom battery packs that I've made, 3D printed, mostly with Lego. And so, yeah, this was a 2020 project because, everything changed.
Yeah.
So,
then there was a big proposal, lots of different things to try and, work on what this was going to be. It was going to be a internet controlled race car, so that anybody for a virtual conference could log in and sit in the driver's seat and be Max Verstappen and drive a Lego car and crash them or something.
I appreciate the design because we've seen quite a few, I guess, microcontroller controlled cars, but this one has a spoiler. Like the whole shape is just beautiful.
Thanks.
Yeah,
Yeah,
I
most of them are
appreciate it.
ugly. There's a
You said it,
bunch
not
that
me.
we looked at, and they're like, oh, maybe we do this, it'd be cheaper, easier. And I was like, yeah, but they're ugly.
Yeah.
This has got to be fast. I also made it so we can have pit stops, so you can pop this pin out. It's gonna fall there, but that's okay. And so the front spoiler comes off. So
Oh, brilliant.
Oh, slick.
I don't know why it didn't all. Okay, well, it's Lego, so
Curse of the live demo.
things happen. Why did that not work? Yeah. So there's you can only do so many Legos one-handed.
Mm-hmm.
That's it.
Or I shouldn't say Legos, Lego. So there's the spoiler. So when you get in a wreck, you can have a pit stop and put a new one on.
Slick.
That's awesome.
It's about the little things. So yeah,
Yeah,
everything's
definitely.
open source on this. There's a custom PCB board, so you can download that PCB board, send it off to Osh Park or any PCB board manufacturer. It's on version 2 or 3. We need to update it, but the Pi cluster has taken priority this year.
Well, definitely,
So
yeah.
what led to the development of this humongous Pi cluster? Was it your idea? Did somebody say we need to accomplish this goal? What got us there?
So we were brainstorming after one of our, we have a conference, and then we go, what, kind of a postmortem, what went well. We did the matrix bullet time. So we had 60 Raspberry Pis in a circle. So you could take a snapshot and stitch it together and do that.
Very cool.
And that was a lot of fun. And 60 Raspberry Pis seemed like a lot. It was. And then we thought, we sat down and had some brainstorming and thought, well, what about doing a big cluster? What's the current, record for it? So we thought, someone said, well, let's do 1,000. And that was going to beat the current record. The current record's somewhere around 700. And when they threw that number out, I said, that's a stupid number. We need 1,024.
Yeah.
So this modular design of 42 in one well, how many U is that? That's 5U. We took that and extrapolated it, and the number we got, it was 1,050. So the running joke is I disable 26 of them to get a better number.
So what model of Pi is it that's in the rack?
Raspberry Pi 3B Plus.
Ah.
Yeah, the 4s hadn't come out yet. One of the questions people always ask is why didn't you do net power over Ethernet PoE? And it's just that the PoE cards, the headers or the hats just didn't work back then. You had to do some custom software. It just didn't work. So we tried. Plus, you couldn't get the density of this. This is the most, had a few different designs. This was the most dense that I could possibly get. 21 Pi. So yeah, these caddies then got printed this year, and we added fans. Well, actually, no, I did that late 2019. This was originally going to ship around the world, and it turned out the power requirements, I can't boot the whole thing up here in the garage because it will take too much power. It takes more power than my house.
That's awesome.
A little over 200 amps. So what we did was we made 2 mini Pi clusters with 84 Pi. And I built one of those in my garage during the whole lockdown. That video did pretty well. And that one, I designed that fan caddy, and we solved the heat problem. And so then fast forward to now, the whole idea was to resurrect the project, and it actually went to e-waste. My lab got closed during COVID. Those were some crazy years, 2020, 2021.
Yeah.
And so I had to fix a few of some things were missing because it went to e-waste. We resurrected it and recovered it, so that was fine. But then I had to take the whole thing apart while it's been in my garage for the last number of months and add fans to it.
How many fans does it take to keep that thing cool?
There's 257 fans.
Wow.
So each one of these has 5,
Mhm.
and they're bolted on the back here, so it blows air through. It gets pretty decent airflow. It's kind of surprising. You just turn on these, and then you turn the air on, and it feels about like your little, a little tiny electric wall heater, or wall, just a little portable one. That's kind of what it feels like. It gets loud. That's why I have it turned off right now. You don't see any blinky lights, but I assure you, I love doing this during meetings. People think I have a virtual background, but no, it's real. So yeah, it takes a lot of fans, and that just the wiring of all those fans took. I mean, everything takes a couple minutes here and there, and you add that up 1,000 times, and there's a month gone.
Wow. So what software is running on all of those Pis to make it do the work?
So it's running Oracle Linux on the server, and it's network booting. So we originally ran Oracle Linux 7 because that was the latest Oracle Linux that came out back then. So we just upgraded it to Oracle Linux 9. The server, we actually have it partially upgraded. It's kind of a long story, but just to rebuild everything, it didn't work. So anyway, all the Pis are running Oracle Linux 9, the latest. That just released actually like 2 weeks ago. And we're running Graal VM, Java, and Python. So Graal has a Python, so Graal Python. It's a polyglot, like Java virtual machine next generation, and you can mix and match programming languages. So there's a Python version of that that's for Pi. It's in a tech preview. Well, not even tech preview. I guess the engineering's still working on it. It's before tech preview. I was hoping we'd get to tech preview for this, but so it's totally beta software, and I feel it, but it's coming along. So every Pi, there's a Python server. There's a few little Java bits in there. It's not as much Java as I would like because I prefer Java, but I'm trying to work on the Graal Python stuff as much as possible. So
yeah,
I have both of those work. There's REST APIs running on each little web servers, running on every single device and the server, and they're all constantly communicating so that you have the cluster, everything's pinging and ponging and health checks and all that kind of stuff. And then we have a bunch of cloud pieces, and the cloud pieces, because we have Oracle Cloud Infrastructure, OCI. I'll just call it Oracle Cloud because OCI doesn't sound as good as I'd like. And we have, gosh, what do we have? We have Autonomous Database running with what's called Apex. So it's a no-code solution to be able to build front ends to databases. We have that running. You can create REST endpoints there. We have just some basic VMs running with also REST services. Again, that's in Python. And there's a whole Kubernetes cluster that's running. So I can open it up here just a second. I'll show you the AR side of it.
Brilliant.
I have this Pelican case packed.
That just shows the height of it. You can completely hide behind it.
Yeah, our guest is gone.
It's awesome.
Let's see here. So we have these iPads that are put into these cases.
Yeah.
And we're gonna. You can see the QR codes. They're little tiny QR codes right there, but they're only 15 mil, but they're really cool, laser etched aluminum. But they don't get enough. Nice. There's not enough. What's the word I'm looking for? Contrast between the aluminum and the aluminum. It actually reflects. If it was white, it would be better. So in the corners, you can kind of see a blue thing right here. I'm going to put a much bigger, instead of 15 mil, it's going to be 75 mil, so about 3 inches. And we'll have those on the outside because they're kind of obscured by the cables and stuff, so it just didn't work. So we have an augmented reality app. So you can take the app and you can see what's happening on each Pi and interact with it.
Oh, wow.
And so that is hosted on a Kubernetes cluster. So all the data from the Pi cluster, every Pi is sent up to the database, the autonomous database server that we have running. And then we have a Kubernetes cluster that's running a couple different, there's this thing for the Pi cluster, for the augmented reality iPad app. And then we have a virtual reality room that you can see this cluster in real time. Well, as real time as we can get. And so anybody during the conference can ping that URL, and you'll be able to see the cluster, what's going on in real time. And one of the VMs that we're running is polling Twitter. And so that's how you can interact with the Pi cluster. So I wrote a custom programming language I'm calling Warble. So it sounds harder than it really is, but background with compiler theory, it's fairly easy, and I took a lot of shortcuts. But basically, I took every chance I could to take a programming language and strip out characters. So you can write a Warble. Oh boy, there's my iPad. Ever since the Pi cluster came here, my iPad started responding and doing weird things. Siri shut off, but it talks to me. Anyway, so you can write a Warble, #Pi, curly braces, and there's you can just print something, or you can calculate Pi. I've gone through and I've written a bunch of different ways of calculating Pi. And so we'll also have that posted as kind of a leaderboard. So you can see, it'll scroll by and you can see what all the warbles that people are posting and what the results of those are.
Can you talk a little bit about the frame that's used to hold this entire cluster together? Because I know you've mentioned the 3D printed brackets. What else do we have going on here?
So these are 4, well, actually there's 5, because there's one vertical rack in the middle, just to hold some of the fans. But these are just regular aluminum server racks, and they're 6 feet tall. And then this is extruded aluminum. It's the black anodized. It's called 8020 is the brand that I typically use. There's some other brands, but they're typical for it. So it's just an extruded aluminum channel system. Yeah, you can put T-nuts in it. I'm trying to think if I have a piece. I don't know if you want to see a piece closer. I can grab one. I have one. And top and bottom. Let me see the top up here. It's just plywood on the top and bottom that I cut with a CNC so that we had all the holes in the right spots. And on the ground is 3D printed. There's casters with 3D printed brackets that the casters bolt into.
That's an awesome piece of work. We've got a question from the audience. I'm put it up now. So Mike has asked, what's the best thing to try and start learning this technology, this software, this hardware, this build process?
Chain link together. So I'm trying to understand what the question exactly is. So is this start learning in the space? So specifically with clustering, I'm assuming. So
I think so. Yeah.
I think Mike's alluding to that. He's struggling to understand how would one Pi work, or having multiple Pis doing all these jobs together. How would you get started in doing this?
Yeah, let alone 1,000, over 1,000.
Yeah. I don't recommend it. It's I disassembled the whole thing and I'm putting it back together, and I had to boot all of them one at a time to make sure that they're working. And I've run into one of them that's just, I don't know why it's not working. So I got to get one of the Linux engineers on the phone here soon. We spend a lot of time SSHing into the cluster. What I've done is I have a Ubiquiti's on the cluster. And my home network is Ubiquiti. I liked it enough after doing the cluster. It was kind of a learning experience. It's kind of in that sweet spot of good enough. It's like pro features. The one thing I don't like is they keep updating the UI and they don't actually fix bugs. So I have some beef with them. But still, for the price, there isn't a better product. And so my home network is also Ubiquiti, and I carved out a subnet right here in the garage. Well, I'm pointing to the garage, but for my garage, and I isolated it for my home network, and then I did a site-to-site VPN to Oracle Cloud. So there's a server up in the cloud that other people can SSH into, and then they're on my home network, but isolated in this little bubble. So, yeah. Let's get back to the question. So, it's, you know, if you want to work on clustering stuff, it's really quite cool. There is some over-the-counter kind of software that you can get that does stuff, you know, some clustering, supercomputer kind of stuff. Just look on GitHub, and I recommend using that rather than writing your own. Although writing your own, you'll never know it better than if you just kind of work that way. What I did, the way this works, I found it to work better, the best way to work on it. So when we debuted it in 2019, I didn't have time to write the software. We actually hired a Java company to do an open source Java community project. So they had some cool stuff running on it back then, but we weren't pushing the load limits on what to do, because it's a hard problem. You know, how do you run something? You know, you take an algorithm and you split it across, you know, just 10 processes. You know, it's just the same programming as parallel programming with threads. So where I got started, at least, was threaded programming. So you take an algorithm like pi, you can just split that up and look at, there's some well-documented ways of splitting that up and executing you know, that in parallel, and then reassembling the output. So that's what this is, or at least I can do that in Warble. So that's one way of doing it. There's or I guess a second, how many ways have I gotten to this? Yeah, there's like 3. So what I did with the cluster is I have a server running, so it's just a REST server, and each Pi, when they boot up, and each one's network booting, so we didn't do SD cards, because that just, imagine having to plug SD cards in there and flash every single one of them. So sometimes we don't get, Pi doesn't come online because it doesn't boot, or there's too much. This is a 10G base, yeah, a 10G network, so there's plenty of throughput. But and it's a pretty beefy server, so it can handle it. But when 42 Pi come booting off of it, do a network boot off a NFS mount, it takes a lot. So sometimes if the timing's wrong, it doesn't quite work. And there's a bug in the Pi 3 anyway. When you network boot,
yeah,
the way the handshaking works, they don't actually with DHCP. There's not actually a full request and lease handshake there. So they request it, but they don't actually hold on to it, and so they just release it back into the pool, and you can have multiple Pis that boot with the same IP address. So we actually have in the dhcpd.config, we have to hard code all the MAC addresses for the Pi and then hard code the IP address. So it's kind of backwards. You're using DHCP, but it's hard coded. So, you know, if there's a bunch of different things you can do here. You can start on network booting. That'd be kind of a fun thing to do from one Pi to another. You can actually do that. If you don't want a network boot, which there's some reasons to, and then there's a lot of reasons not to. So you got to figure out what you kind of want to address. Like I said, I have a REST server running on the server, and then each Pi is running a REST server, and they're communicating. So every 10 seconds, I think is what it is, I have just a UDP message sent out, and that UDP message on port 3333. I don't know why I picked that one. That's just what it is. All the Pi, when they boot up, they're listening to that. And the IP address of the server and the port that the REST server's on, which is 8880. Again, I don't know why I picked it. It was just easy. 88 added to 80. And so the Pi then I don't have to hard code like an environment variable or something like that. So, which is one of the problems we ran into when we did it the first time around is getting that environment variable, because it's just environment variables are kind of weird when we switch from, because we switch around different OSs and different, like Raspberry running Raspbian on the desktop, sometimes running Oracle Linux on a Pi. Anyway, everyone has kind of a different situation when they're running their simulated environment, and then we deploy it on here, and it's different. So the server, I'm now running Docker because it's always the same. That environment is always the same on the server, but there's not enough memory on the Pi to run Docker. So I would recommend someone use a Pi 4 with at least 4 gigs of RAM. That would be the kind of sweet spot. You could run Docker, and then what you run on all the devices could be the same.
Yeah.
And I mean, there's other ways of doing it, but that's what I'd recommend. And then, so then the Pi are listening in, and they can talk to the server, and they can register themselves with the server. So now I can go through the server and find out what Pis are running, what switch they're on, all that kind of stuff. So that's kind of the first step. That's kind of an infrastructure piece. And there are some open source ones, but none of them kind of quite fit the bill for what we were trying to do and what I wanted to do. So hence I rolled my own.
Oh, why not?
I would use an open source one if you can, but if you really want to know what your cluster is doing, then write it from scratch. There's no better way to learn that. You need at least 2 Pi, but it works.
Yeah.
Ping me if you have any questions. I'm around.
That's awesome.
I'll put your Twitter handle up again. There you go. So, Mike, when you've got a few seconds, mate, if you want to take down that Twitter handle, you can ask him loads of questions after the show. And also, we'll have you on the show in 2 weeks' time, Mike. You can talk about your cluster. Yeah.
Yeah.
Brilliant. So, just before the show, Chris, you mentioned that that cluster's moving soon.
Yeah. So on Thursday morning, I get out of some meetings. So there's a big truck with a lift gate on the back. They're going to show up with the crate that was built for this thing, and they're going to take it to Las Vegas. It's going to be going to Cloud World and Java 1. So it'll be in the developer area. And if you want to come and see it, if you're in the area, hotels are pretty cheap in Vegas, but so you can come and see it.
Oh, that's too cool.
That's brilliant.
There's a comment. Oh, sorry.
Will it be working there, or will it just be a showpiece?
It'll be working.
Oh, excellent. Yeah. All the blinky lights.
All the blinky lights, the iPads, all the cloud services will have the, so anybody on the internet, if you're have access to Twitter, you can post a warble to Twitter and it'll run on the Pi cluster. I hope.
And they're ready to power it, because I know it takes a lot of power.
They're ready to power it. That's what I've been told. Yeah.
Good.
Wow.
It takes a lot of power. You can't boot the whole thing up at once because it pulls too much power. So you have to slow and the each when the Pis boot, you can't hit all those on the network, the server. So we have to slowly boot and make sure that they booted. And eventually, after about an hour, we'll have the whole cluster up.
That's amazing. It's almost like Apollo 13 when they're going to power up all the systems in a set order so they don't pull too many amps.
Yep, that's exactly it.
Wow.
There is a comment pointing out the shortage of Raspberry Pis right now, and I had to point it out because if you want to get your Pi fix, you've got to go check out this thing in person, because it might be your only chance to see that many Pis in one room right now.
I was trying to donate it to the Tech Museum, but there's we it turns out getting a Guinness Book World Record is quite challenging. I never tried to get one before. It's expensive, and how do you get an expert that can certify it? So it's kind of difficult. Some other people on my team were doing that, and I don't think it's going to happen just because timing. But It would have been fun.
For sure.
Yeah. Well, Chris, thank you for bringing this project along. It's absolutely fantastic. And this is my segue now into the next section where I say to Ash, hey, Ash, you got some more great projects to talk about.
It's true. A lot of people don't have 1,000 pies laying around to play with, and I'm jealous of those who do. But our pie community is really strong. What they can create is really impressive. So every month I like to gather a list of the best Raspberry Pi projects that we've had the honor of featuring. And it's that time of the month again. So if you want to check out the full list, go to tomshardware.com. Best Raspberry Pi projects. We like I said, we update it every month. But to get you excited, I have a few that I wanted to share with you guys. Let me switch my screen over here. The first one I want to show off is this Raspberry Pi live streaming camera. Now, having a camera on a Raspberry Pi is nothing new, but what's cool about this one is it's an all-in-one unit. It has a built-in microphone, beautiful 3D printed shell, and it can be used to live stream in real time directly from the Pi inside. So instead of, connecting your camera to your computer, this and that, it's all in one go. You can use it for something inside. Let's say you're a gamer, you want to stream yourself while you're playing games, or maybe you want to put it outside and show everybody what cool birds are coming by. I don't know. Whatever you want to live stream, this is everything put together in one place. And it's so beautiful. It reminds me of the YouTube logo kind of, but maybe that's just me. And another one I wanted to share is this Pico powered, well, I say Pico powered, but it uses an RP2040. It's a hex color picker. So if you're a maker who has a ton of RGB LEDs that you want to play with, and you pick a color out on your computer screen and send it to the LED, it doesn't always look exactly like how you want. So what this device lets you do is spin these little potentiometers to dial in a specific hex code. And you can see that there's a light here off to the side, an RGB LED behind. It's actually a keycap over top of a switch. And as you adjust the potentiometers, it will change the color in real time. So you can dial in the exact color that you want using an actual LED. And when you want to save that color, you just press that button and it'll send the value to your computer. It's called the dial toner. And if I'm not mistaken, the maker, Guy DuPont, is selling them on Etsy, or at least he has some prototypes, and there might be a modified version in the future. But in addition to these Pi projects that people have made on the list, we also have quite a few guides and tutorials made by Les and Avram that are really neat to check out, especially if you're new to Pi projects. Maybe you just want to follow along, get familiar with how to set up a project, use it to inspire future creations, yada, yada, yada. So I wanted to show you guys this really cool guide that Avram's put together on how to make a Minecraft server on Raspberry Pi. If you're not new to the community, you should know by now that Minecraft is no stranger to the Raspberry Pi. They even have a Raspberry Pi edition of Minecraft that comes loaded on the default Raspberry Pi OS. But this is a way for you to create a whole server for anyone to connect to, not just anyone local on your network. If you set it up following this guide, you can play the full version of Minecraft. This isn't just for the Pi edition. So if you want to tinker on your Pi and have an excuse to game a little under the guise of just testing your creation, you should definitely check out this one. But again, that's just a little taste of what we have on our best projects of the month list. Go to Tom's Hardware and check out the full list. It's awesome, I promise. I'm biased.
Thank you very much, Ash. Right, it's my turn now. So I'm going to talk to you about something different. It's not a Raspberry Pi, it's an alternative. I know, we're going to cover something that's not a Raspberry Pi tonight. Here we go. So we all know and love the Raspberry Pi, but we all know you can't find them. They're rare. Rarer than hen's teeth, you could say.
Chris took them all.
In 2019 he did, yes. Not now.
I did buy them recently.
That's fair, that's fair. They were easy to get a hold of back in.
They were not easy to get hold of now. I mean, they're still producing, I think Eben Upton said via Jeff Geeling's video the other day, 400,000 pies are being produced per month.
Wow.
But there's still high demand for these products. And a lot of them are going now to the industrial sector, to OEMs, to put into products. So the amount of pies coming to the market is less for us as consumers, which is unfortunate. But they are looking to ring fence a certain number of pies so that retailers, resellers can get these boards into the hands of eager hackers like us all. But if you can't get a Pi right now, you need something else. So you could go for a Pico W, or you need simple, basic microcontroller. You need a bit more power, you could go for, and here we go, Khadas Vim 4, which I've done a review for recently. Really nice board. It's expensive compared to a Pi, but at the minute, Raspberry Pis are also expensive. But it's got immense power. But Khadas sent me something else to play with. And it looks very much like the Vim 4, but it's the Edge 2 Pro. Let's get this camera to focus. There we go. That's a YouTuber trick. So you can see it looks very similar to the Vim 4. But the two are very different. This little board has got 16 gig of DDR4 straight off the bat.
Wow. And
an octa-core processor, an RK3588S SoC, which has got lots of power to it. I'm just going to go to my second screen. And that means I can put down that, so I can do some stuff now. You can see, there we go.
What are those ports it has?
Well, very handy that you've asked, because if I just scroll down here, we can see what it's got. There you go. So we've got an octa-core processor, 8-core, 64-bit CPU. We've got 4 CPUs at 2.25 and another 4 at 1.8. So it's pretty nippy. And let's scroll down to the ports. Oh, there we go. RAM capacity. The basic model is 8 gig, which is still immense, and it's got a 32 gig eMMC. Model I've got is the Pro version, which is 16 gig of RAM and 64 gig eMMC. It's got wireless. There's no Ethernet on this, and the Khadas Vim 4 had Ethernet, which was really handy because I've got really poor Wi-Fi where I'm sat right now. But hey ho, we can work around that. The Wi-Fi on the board, it works really well for me. I can download via UWOW, which is the installer. I can download Ubuntu, Android, that sort of thing. It's all pre-done for this board. So I'm going to go and download an ISO and make my own image. It's just a case of open up UWOW, which is just like a BIOS almost when you turn the machine on. So the OS that I want, it downloads it all. It's all pre-configured for the board. Boot into it, and away I go. And performance is pretty decent. Now, I've still got all the tests to do for this, but it's almost like having a miniature desktop. Now, the Latte Panda, which I reviewed recently as well, which is the Intel board. Which way up is it? There we go. I'll get this right one day. It's only 102 shows. There we go. This is a powerful x86 SBC. This is a desktop experience. But the Edge 2, it's just even more powerful. And I just can't believe you can do that with something so small. So let's get down to the port, which is where we all really want to know what's going on. There we go. So USB 3 on the left-hand side, top left port. We've got 2 USB-C ports as well. One will do display ports and power. One's power only. And it runs from my bench supply. I've got about 12 volts, which is absolutely fine. USB 2, as we know there. So that's the basics. We've got a load at the bottom of these connections. So these are like the CSI and DSI connections to the Raspberry Pi. We're connecting cameras and screens, that sort of thing. So you can plug in different screens, different cameras, and away you go. On the underside of the board, we've got pogo pins, which is just underneath the HDMI port. Oh, and by the way, this can do 8K output, which is really impressive. Wow. 4K video playback in Ubuntu is a bit not too good at the minute. It's got a 1 gigahertz GPU, but I found that when using YouTube on Chromium browser, it was a little bit slow, but there's no hardware acceleration there. So hopefully a driver will come out and fix that, but we'll see. We've got some pogo pins on the base of it all, just underneath the HDMI port, and there are only GPIO. So if I switch back to my camera so you can see me, the Khadas Vim 4 had a 40-pin GPIO just at the top. There you go, just there. This has not. So that's... Let's get them both in shot. There you go. You can't see a GPIO at all on that one. So, is it going to be a maker board? We'll wait and see what we can do. There could be something that we could do with those pogo pins. I mean, I've got some pogo pins knocking around somewhere. I could test that out. And we can work out what it's like. Well, there's going to be a review on Tom's Hardware pretty soon. I'm in the process of writing it up. But yeah, interesting little board, and the price of it, we're looking at about $300. So it's a big chunk of money. If I go into the page now and go to the shop to buy one,
Do they all come with the heatsink and fan?
they come with the basic heatsink and fan. Yeah, the one that I've got on mine right now. There is a kit that you can buy as well, which fits over, like it makes it into almost like a desktop PC. Think of the Argon 40, which I'll just grab mine. Look, it's handy. It's on the table like this, the Argon 40 type stuff.
Okay.
So that's quite good.
If heatsink and
Yeah,
fan works, then that would be pretty cool, because the ones for Pis are difficult.
Yep.
Yeah, definitely. Definitely. So Edge 2 starts at $199.90. That's for the 8 gig model. There we go. And we want the basic. Yep, there we go. So that's a very basic kit. The one I've got in front of me right now is the Maker kit, but it's the Pro version, and that's $299.90. So it's a big bit of money to spend, but you're getting a hell of a lot of board for this. So I'm quite impressed. But yeah, a review's coming soon on Tom's Hardware. I'm just going to check for any questions and we're coming out. Let's see. No, we're good. Okay. Well, let's go back so you can see everyone. That's always good to see. There we are. You don't want to see me all the time. I'd like to thank Chris for turning up tonight and a very last minute. Thank you very much, sir. And that is an impressive piece of work. And we're going to put your Twitter handle up again so people can see your work. They can see your YouTube videos and understand what this piece of work can do. It's awesome. And the fact that it's the size of something from a British TV sci-fi show that we can't name for legal purposes is absolutely fantastic. So thank you very much for bringing it along, Chris.
Thanks for having me. It's been fun.
No problem. And that's all for this week. We'll be back next week at the same time, 2 p.m. Eastern, 7 p.m. UK time. We'll see you next week. Thanks very much.